Lesson 8 is on naming covalent molecules. We will be discussing the prefixes that are involved in binary covalent compounds and the rules for naming them. So, binary covalent compounds are composed of two nonmetals that are not ions because we're talking about covalent compounds. Rules are different from naming ionic compounds. We are going to be using prefixes to tell how many atoms of an element are present in each molecule of a compound. Molecular compounds, or covalent compounds, that have more than two elements will be covered later on this year in organic chemistry.
So these are going to be some of the prefixes that you need to know. You need to know these because they are not in your reference table. So take the time right now and copy down the prefixes and the numbers that they represent. They are incredibly important for when we want to name covalent compounds. So the rules are incredibly simple for naming. You're going to find the less electronegative element. That's a nonmetal. That one is going to be named first. Then you find the other one, which you're bonding with, which is obviously going to be more electronegative. And the ending of the second will be reverted back to "-ide", very much like ionic. However, you have to put the right prefix in front of each element to tell how many atoms are in that molecule. But there's a catch. We do not use the prefix mono on the very first element. Mono is only going to be used for the second element. So for example, mono, which is a sickness, the first element never gets sick. That's something you guys should remember. If you never get sick, you can never have mono.
Generally, the atom that is furthest left on the periodic table will end up going first. If both atoms are in the same group, the atom that is further down is going to be the one that goes first, because this goes back to our trends.
As you go to the left of the periodic table, electronegativity decreases, and as you descend or go down a group, you're also losing electronegativity.
Honestly, when in doubt, check table S.
So here are two examples. You have silicon and you have 4 fluorines. And in the second compound, you have 2 nitrogens and 3 sulfurs. So if we had to name them, would we call that one monosilicon?
No.
That's rule number 5. You can't do that. So the first one we call silicon tetrafluoride. What does tetra mean?
Tetra stands for 4.
Oh.
You've heard of a tetrahedron before, right?
No. I heard of tetras. They're fish.
Tetrahedrons are 4-sided figures, like squares and
That's
rectangles.
Like math class.
Yeah.
Gotcha. Well, in our second compound, I have 2 nitrogens. Does that mean I have bisodium?
Bis.
Well, bi means 2, right?
No, it's going to be di in this case.
Okay, and 3 is tri?
Yes.
So that's dinitrogen trisulfide.
Right.
Check it out. I said sodium for nitrogen. Ha. So here are 4 more examples we want you guys to do, and I specifically color-coded them to help you guys out. So remember, the prefix is talking about that element specifically. There is no crisscross method. So in the first one, you have diboron hexahydride. That's between boron and hydrogen. So di means 2, hexa means 6, so your formula is B2H6.
Nitrogen tribromide would be NBr3.
Sulfur hexachloride would be SCl6.
Diphosphorus pentoxide would be P2O5. Notice that we have also dropped one of the vowels in between penta and oxide. It's proper to only keep one of those vowels.
And you're never going to have 2 O's in any of these words. And it just sounds ridiculous when you try to say pent-oo-oxide.